Because you'll see that the
Yeah,
that the
and
y
then
direction is still
subtraction,
positive.
Subtraction.
So it rebounds like
Huh?
that. So it's
No,
going to be
these are,
positive
the
x.
finals are added.
Or
Okay, they're both added, but the fact that
yeah, at the
It's a
beginning it's
negative
going at the
velocity.
positive x,
that's
a
where we get our negative one.
and then it's going in the
For which
negative
one,
x.
sorry?
But
First
they're
of
both
all,
going to be
yeah.
positive wise.
Yeah,
That's
so it's a
right.
negative velocity
Okay.
at first, and it's a positive velocity.
What is the
That's
impulse
why
exerted
that's
on the
a
ball
plus
by the
That
wall?
makes sense.
Cool.
And when you said them equal to each other, what do you mean by that?
What are things
By
given?
saying,
What's our
like,
velocity? Initial?
BRI,
Is 4I plus 3J.
just said the two equations.
No, is it
equal to
4i?
Yeah.
4I plus 3J.
And then it's negative 4i,
Plus 3J. Yeah.
3j. Okay, and our mass is
3 kilograms.
3. Cool. So we have to break it up in the x and y as well.
Okay.
We start with your beginning, so initial, momentum initial, and then momentum final. That's what that means, it's momentum. So guys, so just for you guys, if you wanted to pay attention, it's on the wall, the ball's hitting a wall, and it coming off at an angle. That's the velocity initial, that's the velocity final. And so we're trying to find the impulse that the ball feels.
So you just take the area?
Not the area.
Well, we're looking for the impulse exerted on the ball by the wall.
Mhm.
On the ball by the wall.
Yeah.
Okay.
And it'll be the same. The ball and the wall and the wall and the ball. They'll be it's like opposite reaction pairs. It's like the force I put on the wall is the same as the wall put on me. And so, yeah. Solve for either one, you get the answer, which is nice. So we have to do the momentum initial and final in the x and in the y. That's a y. In the x, it's going to be your velocity in the x.
Times the mass. Plus 9.
In the velocity in the
That's 3 times 3, right?
negative 4 times 3. Yeah, that's a 3. And then it's plus
Plus J.
j in the x.
The same as the other one, right?
Yeah, so it's going to be 3 times 3 is equal to 3 times 3 plus j in the y. For you guys, just so you know, to find what impulse is your mass times velocity initial is equal to your mass times velocity final plus j. J is your impulse for you guys. And so that's what we're looking for. We're looking for the impulse in the x and in the y, because you need to break them up into x and y. It's like forces. Yay, we're back to that again, right?
Why are you breaking up from x and y?
So we have these velocities, and it's hitting a wall and bouncing back off. And we want to find the impulse. So to do that, you have to find the impulse's components. And to do that, you use that formula. Your initial is equal to the final plus impulse. So did you get what the impulses are?
Yeah, the possible answers.
Yeah. So like jx, what's jx equal to?
Looks like
Maybe 8.6.
24.
Yeah, oh wait. Oh, that's not a point. Sorry. I thought the same thing.
Ah, it's gonna
Yeah.
be
It's 12 plus
24.
4.
24.
24, that's in Newton seconds. Then what's jy?
0.
0. Now look at this. Let's see why that is. As you hit this wall, it's saying that the impulse is directly this way, which just changes that velocity from that to that. It doesn't change it in the y at all. It just changes the direction that that the ball is going in the x. So there's our things. Now, how do you find the total j? Sum of the squares, but that's just
Use add them up.
Yeah.
Yeah, what if you make like the final component of the velocity? So instead of having like in x and y, you take the hypotenuse of that one,
Of this one?
of both of them,
Both of them.
and you work with that magnitude. So it's gonna work.
Let's find out. That's going to be 5 And that's gonna be 5.
Yeah, because that's what I had.
So then from that, 5 times 3 is equal to 5 times 2 plus. That'll get 30. You'll get 30, dude, 30 Newton seconds. Or is 0? Yeah, we won't be able to do that just because here we lose information. If we do that, then we lose information about which way they're pointing. And it's that direction that helps us to find the actual answer. It's kind of like forces, how you had to always break up forces into the x and into the y.
So it's better to do like with the components when you're finding the magnitude of the final impulse, then you do the thing.
Yeah.
Quick question.
Yeah.
So I set them equal to each other.
Okay.
So
So it's positive
if you choose
24.
the system correctly, its momentum is conserved, so
positive
equate
24.
your expression for the initial and final total momentum and then solve what you want to find.
Hey, nice.
So, can I subtract this from this?
What are you looking for?
It just says pick something and solve what you want to find.
So you're gonna solve for which one?
Let's say final velocity.
Final velocity of A? That one?
Sure.
Okay, cool. Yeah, so you subtract that across.
That would be 0.
What's that? Well, you're gonna subtract that, because that has a velocity.
Okay.
So you subtract that across, then you divide by MR.
So, they don't combine. I guess that's my question.
Yeah, they don't combine.
Okay.
Just because they have different values and they don't equal the same thing. Does that make sense how this whole thing works, how you have to break it up into
Yeah.
different
X and
components?
Y. Yes.
Okay. Car was initially traveling directly east.
Basic grace is
Can I see the paper? I'm gonna draw the
Okay.
picture.
What'd you
Yes,
do
okay.
here?
Thanks, man.
So in this case, it's
To
positive,
solve
right?
for velocity final.
Yes. Yeah.
Thank you, Chris.
Okay. So it's saying that a car, is moving to the right. It has 1200 kilograms at a speed of 25
Can you really turn
meters per second. It crashes into the rear end of a truck, and so the truck is moving the same direction, just at a lower speed. It's going at 20 meters per second at 9,000 kilograms. That's before. After,
Is there a book assigned?
No, I'm doing tomorrow's homework.
Oh, okay.
see, you heading out, Chris?
Yeah.
Okay.
I still got other homework to do.
Cool. So it says after the collision that the car has a speed of 18 meters per second and the truck has something, we don't know. V final. Same mass as everything. We don't care about the loss of the car top that flew off when it got collided with. We're just keeping everything intact. They're like Halo trucks where they're indestructible. So that's our before and after, and we need to find the V.
Okay.
So when we start with our equation, we have your momentum initial is equal to momentum final. In this case, there is no impulse, it's just, does it say the impulse?
No.
No. Okay, so we're just assuming that the impulse is 0, that there is none, that J is 0.
Yeah, how can you do that? How can you assume that the input is 0?
If they don't give it to you, then it's safe to assume that. If they don't even ask for it or mention it at all, then it's safe to assume.
So how could you what's your definition for impulse?
Impulse is the loss of momentum of the system. It's like you have this much momentum and then you have a collision and you only have this much left. What was taken out is your impulse. It's basically the force that needed to move the object. Like if you have a ball of clay, if you drop it on the ground, it has some momentum right before it hits. But all that momentum is turned into impulse because that had to, the clay had to be shaped somehow, had to be squished. Like a bouncy ball, it's very resilient. It will almost go back to the same spot, but it will never get back to the same spot because it loses some of that momentum for when the ball squishes, and then it has to go back out. That motion of squishing, that makes it lose momentum, and so that's what the
So
impulse
that
is.
law would call it impulse.
Mm-hmm.
Okay.
And in reality, when you are in a head-on collision, or when you're in a collision, you're going to lose energy from crushing the cars. Some of that momentum is going to be lost when the cars are going to be dented in. And just in this case, we assume that energy or that momentum is conserved, that P naught is equal to P final. And if it'll tell you when you need to find impulse or when you need to include it. And if it doesn't tell you,
We just assume there's no impulse.
Yeah.
Okay.
So then your momentum initial is your mv plus mv, mv plus mv. This is for the car, truck, truck. Now you plug and chug. Because you have the masses for everything, you have all the velocities except for one. That means you have one equation, one unknown. You can just plug it into your calculator and hop on down to the answer. Yeah.